Okay, section, I think it's 2.3, let me make sure. No, 2.4, I'm sorry. Did I write 2.3? No, I wrote 2.4. Okay, section 2.4 video, part 2, and we want to pick up on the slope of a line. Now, let me talk to you a little bit about this first. First of all, the slope of a line is exactly what you think it would be. It's the angle at which it runs. So the steeper the line, the bigger the slope. Just like if you're talking about the speed of the car. The faster it goes, the bigger the speed. So the slope of a line, the steeper it gets, the bigger the slope. Now, slope can be positive, which means it goes uphill from left to right. But slope can also be negative, which means it goes downhill from left to right. We'll talk about that in a few minutes. But let's talk first of all about a line with a zero slope. If a line has a zero slope, what do you think it would look like? It'd be perfectly flat. Like if you're walking on a floor, it doesn't have a slope. It doesn't go uphill or downhill. So a horizontal line, has a slope of 0. And from this point on, anytime you see the letter little m, it's just the letter that we use for slope. Now, I know you'd say, well, why don't we use S? Because we use S for other things in mathematics and in science and physics. So the letter little m is the letter we use for slope. So a horizontal line has a 0 slope. Okay. Now, let me give you a definition for slope. By definition, slope is defined to be rise over run. Now, that's not a formula, but it is just a fact that you need to know. The definition of slope is rise over run. Now, let me just give you an example of something in everyday life you hear, and you may have never heard of this, but let me give you the example anyway. If you ever hear a roofer, when they're talking about a house, they'll say that the slope of the roof is a 3-5 slope. A 3-5 slope, they don't use the word slope in roofing, they use the word pitch. They'll say it has a 3-5 pitch. That means 3 over 5. Now let me explain to you what that means. Let's suppose I told you that a line had a slope of 1/5. Now here's what I'm going to do. I'm going to give you a starting point. Let's start at the point 2, 1. Now let me say this first. What I'm talking to you about now, where you start, is irrelevant. I could have given you a starting point anywhere. So I could have put -3, 7. I could have put 0, 1. This is just the starting point that I pulled out of the hat. And again, because that's not part of the problem. It's talking about, but you have to have the starting point to graph it. All right, so let me show you what a line that has a slope of 1/5 would look like. If I draw this line, and I plot the point 2, 1. That would be 2 to the right and up 1, right there. So there's my starting point. Now, if the slope is 1/5, slope is defined to be rise over run. So here's what you do. A rise is a vertical movement. That means up or down, just like you're riding on an elevator. Now, run, the way I do it, run is always to my right. Run is always right. Rise is either up or down, depending if this is positive or negative. So rise 1 would mean go up 1. Run 5 would be go to the right 5. But when you do that, you go from your first point that you plot. That's the only reason this point matters. So if I put my pencil on this point, it's easier to count if you've got a grid. If I go up 1, right there, and then over 1, 2, 3, 4, 5. So up 1, then over 1, 2, 3, 4, 5. There would be my next point. And there's my line. You say, well, Mr. Ryan, that line's pretty flat. It is. And the reason is that slope is a real small fraction. Remember we said the bigger the number, the bigger the steeper the line. So let's suppose I had a line of slope 5. This is rise over run. Now I think what I'm going to do is I'm going to use this same graph just so that I don't have to draw another one. So this line right here has a slope of 1/5. Okay, so now if the rise is 5, that would mean go up 5 and right 1. But you still do it from this starting point. So I'll go right here and go up 5. So I've got to, sorry, I ran out of room. So I go up 5, 1, 2, 3, 4, 5. Then I'd go to the right 1. Now draw the line there. And that line right there has a slope of 5. So in the slope world, is a slope of 5 pretty steep? Yeah. 1/5 is about like this. And then 5 is really steep. And so, if you're looking at it like this, I keep doing that backwards because I'm used to the class looking at me. So 1/5 slope would be like this. Slope 5 would be really steep, like that. So, the steeper the line, the bigger the slope. Now, think about what a slope 50 would be. That would be up 50, but you still have to go over 1, don't you? So slope 50. Now, what about slope 5,000? Go up 5,000, but over what? Over 1. So is a 5,000 slope vertical? No, it's not. It's close, but it's not vertical. So what happens is the bigger and bigger and bigger that slope gets, the closer and closer and closer that line gets to vertical. So a 5,000 slope may look like that, but it's not quite vertical. As a matter of fact, the bigger the slope, the closer to vertical. Now, when you hit vertical, here's what we say. We say that the slope is so big, we don't even give a value to it. So if I ask you what's the slope of a vertical line, if you said infinity, you would be correct. But what we do and say, instead of calling it slope infinity, it's just so astronomically big, we just say that the slope of a vertical line is undefined. A vertical line has an undefined slope. And again, the reason is it's so big we just don't put a number to it. So the only kind of line that we do not give a slope to is a vertical line. Here's the easiest way for you to remember that. Think about slope as anything that you can walk on. Can you walk uphill? Yes. Can you walk downhill? Yes. Can you walk on flat ground where the slope is 0? Yes. Can you walk up a tree? No. So a vertical line is the only kind of line we don't assign a numerical value for the slope. So slope is, we call it undefined on a vertical line, straight up and down. Now, let's look at one more example. Let's suppose that I had a slope of, say, -2/5, and let's suppose my starting point was at -3, 1. Let's just see what that would look like. So let's see, I'm going to count, I think 5 spaces in every direction will be enough. If it won't, we'll add them. Okay, so here's my starting point. -3, 1, that's to the left 3 and up 1. So there's my starting point. Now, slope. Slope is negative 2/5. First of all, remember this. Anytime a fraction is negative, the negative does not apply to both of your numbers. Here is why. If you apply the negative to both numbers, what is a negative over a negative? It's a positive. Then that means the fraction is not negative anymore. So this negative does not apply to both of these numbers. What I typically do is I always apply the negative to the top number, never to the bottom. That's why I say my rise is positive if it goes up, but it's negative if it goes down. So I would say the rise is negative 2, that means down 2. But then the run is still to the right 5. So go down 2, right 5, from the point that you plotted. So I would come right here, go down 2, that's 1, that's 2. Then go to the right 5, 1, 2, 3, 4, 5. There's my next point. Now, what do you notice different about this line as opposed to the others we drew? Notice that this line falls from left to right, which validates what I said earlier. Remember, we said if a line has a positive slope, it goes uphill. If a line has a negative slope, it goes downhill. It falls. If a line has a 0 slope, it is perfectly flat, horizontal line. And then if a line has an undefined slope, it's a vertical line. Now let me tie something else in here, just to remind you. You'll see why I do this in just a minute. Remember what we also said earlier in a note was this. If an equation has just an x in it, it's vertical. Just a y, it's horizontal. All right, let me go back. So this right here, this equation right here, has just an x in it. So that means it's vertical. So that also means this equation has an undefined slope. This equation has just a y in it. So it's horizontal. So that line has a 0 slope. So remember, a horizontal line, you'll have just a y in it. A vertical line, just an x. You're going to hear me say that a whole bunch throughout this section. Okay, so that's a little bit there about slope. Now, let's go back. To what we were talking about earlier. First of all, know that this line right here is a slanted line. How do I know it's a slanted line? Because it has both an x and a y in it. Not only that, this equation is in standard form. Now remember, I told you standard form is not a big deal for us. Standard form just simply means the x's and y's are on one side, the numbers over on the other. Now, this is very important. A line can also be put in another form. So in other words, you can manipulate this and make it look different, and it's in a different form. Let me give you an example. I think you've heard me use this example before. If I take Play-Doh and drop it out of a can, and it's just sitting there on the table, and then I pick it up and I squeeze it and mess it all up. Now, has the form of it changed? In other words, is the shape different? Yes, but it's still the same stuff. So it turns out that I can squeeze this and mess this up. It's still the same graph. It's still a slanted line, but it won't be in standard form anymore. But there's another form that we like to put lines in, and here is why. It is helpful when we go to graph it. So, take down this note. If we have a linear equation and we solve that equation for y, we give this equation a special name called the slope-intercept form of the line, which is y equal mx plus b. Okay. All right. So let me explain to you what that means. This problem right here is in standard form. This is in standard form. Now, you just took a note that said this. There's another kind of form that we like to get linear equations in, and it's called slope-intercept form. Now, what does that mean? Read back over the note that you just took. If I take this equation and solve it for y, get the y by itself. And by the way, in this equation, is the y by itself? No, it is not. So if I solve this equation and get the y by itself, we give that form a new name. So here's what we're about to do. Here's my Play-Doh. We're about to mess it up. It's going to be the same stuff. It's going to look different. We're just going to mess it up. All right, so let's do that. So I want to solve this for y. All right, so move the 5x across. And when I do, it becomes negative 5x. And I'm going to put it first just simply because I want to. Now, divide by the number in front of y. Divide by 2. Now, when you divide the right side by 2, instead of dividing the entire side, which I could do, divide it separately like this. So this would be y equals negative 5 over 2x plus 10 over 2, which is 5. The note you just took said when you do this, it is no longer in standard form. We call this slope-intercept form. Now, what was slope-intercept form? What did you write? I'm going to write it right up under here. Y equal mx plus b. So m, which stands for what? Slope, is what's in front of x. So what's in front of x right here? Negative 5 over 2. That means the slope is negative 5 over 2. Now the letter B is the letter we use for the y-intercept. The y-intercept, we use the letter B. And what's in B is 5. 5. Now never mind what we're going to do with this. So here's what I'm wanting you to get from this. If you take any equation and you solve it for y, if it's a linear equation, and you solve it for y, the number that is in front of x is always your slope. So you say, Mr. Rayner, is the slope always the number in front of x? No. It is after you solve it for y. Because see what number's up here, what number's in front of x here? 5. That wasn't the slope. So you have to solve it for y first. That's what we call putting it in slope-intercept form. And the intercept that it's referring to is your y-intercept. So this is going to be your slope, and the number on the end is your y-intercept. Now, it will ask you in the homework to write the y-intercept a lot of times as an ordered pair. The y-intercept is the ordered pair 0, 5. And the reason is, where is 0, 5 at? None left or right, up 5. So all y-intercepts is 0, whatever that number right there is. Now, what's the purpose in this? Don't know yet. Hadn't talked about it. So here's the takeaway of what I want you to get from this video. A line that goes uphill from left to right, positive slope. Falls, negative slope. Horizontal line has a zero slope. Vertical line has an undefined slope. If the linear equation has x's and y's in it, it's a slanted line. If it has just a x, it's a vertical line. If it's just a y, it's a horizontal line. And then a line, if it has two letters in it, can be in two different forms. You can put it in standard form. That means put the x first, the y next, the equal sign, and the number on the other side. Or you can put it in slope-intercept form, which is going to be more helpful for us. And the way we do that is we take that linear equation and we solve it for y. And when you solve it for y, the number that's in front of your x is the slope of that line, and the number that's on the end is where that graph crosses your y-axis, which is why it's called the y-intercept. Okay, and how we will use that in graphing lines, we will see in the next video. So coming up, part 3 video.